guys, तो कैसे हैं आप सब? I believe you are all fine. So in this part we'll be discussing the part 5 of complex number, and therein we'll be discussing the modulus of concept number, the complex number. That concept will be discussed in brief, and even its properties will be discussed in further. So आज के इस पार्ट में हम लोग मॉडुलस ऑफ कॉम्प्लेक्स नंबर के बारे में डिस्कस करेंगे और उसके प्रॉपर्टीज को भी सीखेंगे एक एक करके एग्जांपल के तहत. So without any delay, let's start with our topic, that is modulus of complex number. So आप लोगों के दिमाग में जरूर चल रहा होगा कि ये modulus of complex number होता क्या है, but you must have learned the word that is modulus in your basic classes also, which means that modulus is a function, in which any digit comes irrespective of its sign, like positive or negative, the output will be always positive, isn't it? कोई भी डिजिट इसमें जाए irrespective of its negativity और positivity, the output हमेशा हमें पॉजिटिव ही मिलती है. वो एक ऐसा फंक्शन है, ऐसा हम लोग बेसिक क्लासेस में भी पढ़े हैं. So let's start with the proper definition of modulus in the chapter of complex number, what the role it plays and what are its consequences. So let's start now. Suppose we have a complex number, let it be z, that and its components in the real part will be x, and in the imaginary part we can have its component as y. Then this completely completes a complex number. So what is the role of modulus in this part? The role of modulus in this part will be like something like this. See, it becomes the modulus of z. So this z can be written as modulus of z. This z can be written in between both the bars, that is the modulus of z. But what about this thing? What changes will take place and how does it occur here? Let's learn with the graph first. Suppose if you have to plot this point on a Cartesian plane, so what we'll do? अगर एक Cartesian plane पे हमें इस point को plot करनी हो तो हम लोग कैसे करेंगे? Suppose हमारे पास ये एक हुआ y axis in a Cartesian plane, and this is the x axis, which is going to be real and imaginary axis respectively. So this will be the real axis and this be the imaginary axis. If this is the imaginary axis, then it will be the y axis as we normally learn, and ये हमारा हो जाएगा x axis. So अगर हमें इस point को plot करना है इस Cartesian plane में, तो this is the origin having its coordinates at 0,0. That's the x and y coordinates of origin, and this point will be suppose any point like this one be x, y, a point on a plane at random anywhere. कहीं भी हम लोग ले सकते हैं x, y पॉइंट को. तो हम कैसे बोल सकते हैं कि ये पॉइंट x, y हुआ? क्योंकि ये x एक्सिस की तरफ से x डिस्टेंस मूव करेगा. x एक्सिस पर x डिस्टेंस मूव किया. दिस इज द x, दिस डिस्टेंस इज x, and on y axis or parallel to y axis it moves a distance of y. So we can say that this be the point x, y. Okay, और इवन ये डिस्टेंस भी हमारा x होगा and ये डिस्टेंस भी हमारा y होगा. So till here it is clear. This is the real axis. On this x axis we will be denoting all the coordinates of x, and this be the imaginary axis. इस पर हम लोग imaginary part को दर्शाते हैं like the y component of or imaginary component of a complex number. So now what is the role of modulus in this? In this Cartesian plane हमें modulus का क्या रोल है वो हमें पता करना है. इस z को, इस mod of z को, ये modulus of z इसमें कहाँ डिनोट होगा, कहाँ कैसे इसका क्या महत्व रहता है वो सीखते हैं. तो सपोज ये x, y पॉइंट हुआ, ये बोला कि हमें ओरिजिन से कनेक्ट कर दो, तो हमने सोचा कि ठीक है भाई ओरिजिन से कनेक्ट कर देते हैं इसको. अगर इसे ओरिजिन से कनेक्ट करनी है तो बीच का डिस्टेंस क्या रहेगा? तो यू मस्ट हैव लर्नड समथिंग कॉल्ड पाइथागोरस थ्योरम. ओके, पाइथागोरस थ्योरम in your basic classes. What it says, suppose if you have a right angle triangle, so right angle triangle में जो हाइपोटेन्यूज होता है, हाइपोटेन्यूज का स्क्वायर विल बी इक्वल टू द स्क्वायर ऑफ बोथ द साइड्स, will be equal to the sum of square of both the sides. Like suppose if this is the hypotenuse, then this will be the one line and other, this will be the height and this will be the base. So what it says, hypotenuse का square, this will be the, suppose this is mod z and this will be nothing but under the root a square, no it's x here, we need to write x component is x here, so it's x plus y square. How we can do so? Because by the Pythagoras theorem we can see that this a, let this be a point, this will be, and this be c and this be d, then we can say that ab square plus bc square will be equal to ac square by Pythagoras theorem. So we can say this, okay? And how we will be trying to find out its distance? The distance will be something like if AC square we have to find out AC, the distance AC, this point, then we can say the under root AB whole square plus BC whole square. What is the distance of AB? Distance of AB is x, so it becomes x square, and BC becomes y, so it becomes y square. So thus we can say that this point is going to be the this is going to be the distance between the point A and C, and there this is how we represent this is the role of modulus of complex number in a Cartesian plane. So in order to find the modulus of a complex number, what we need to do, we need to just square the real part and then the square root of complex part, imaginary part, and then under the root. That will be the role of modulus of complex number. Let me write it clearly for this. The general form for modulus of complex number will be under the root x square plus y square. We need not to keep only x or y, we can keep any variable, or even we can write it in a general form like under the root real part of z whole square plus imaginary part of z whole square. This will be the general form for finding out the modulus of complex number. I believe आप लोगों को बहुत अच्छे से समझ में आ रहा होगा. Let's take an example. Let's take an example to find out the complex number of a given complex number. Suppose हमारे पास एक complex number दिया गया है z is equals to 2 plus 5i. तो हम इसका complex number का मॉडुलस कैसे निकालेंगे? मॉडुलस ऑफ z will be nothing but as the formula says under the root real part of z का होल स्क्वायर हो जाएगा. ठीक है, सो रियल पार्ट क्या है यहाँ पे 2 का स्क्वायर हो जाएगा यहाँ पे प्लस इमेजिनरी पार्ट का होल स्क्वायर. सो इमेजिनरी पार्ट इज 5 and if you do square of it becomes what? 2 square is 4 and 5 square makes it 25. So finally we can say that the modulus of z is 29 by this question. Okay, so I believe ये भी आप लोगों को बहुत अच्छे से समझ में आ गया होगा. Now let's continue further with its properties. So guys, continuing further with the properties of complex modulus of complex number. In properties of modulus of complex number, total we have 8 properties. We'll be trying to complete it in this part, and if not completed then we'll be continuing further in the next part also. So let's start with the first property, and before that let me tell you in the other language. So आज हम लोग properties of modulus of complex number के बारे में डिस्कस करेंगे. हम लोग टोटल 8 प्रॉपर्टीज सीखेंगे और उन्हें एग्जाम्पल के तहत अच्छे से सीखने की कोशिश करेंगे. So let's start with the first property. First property of complex number, that it says that suppose we have a complex number z, then its modulus will always be greater than or equals to 0. Its modulus will always be greater than or equals to 0. It gets two parts, like either it will be equal to 0 or it will be greater than 0, isn't it? Either this modulus will be equal to 0 or this modulus will be greater than 0, then this condition satisfies. So in order to have the conjugate as 0 and the modulus of complex number as 0, we need to have its real and imaginary part both as 0. Like it will be purely real and purely imaginary complex number. Then only we can say that its modulus will be 0, and then this condition satisfies this first part. And the second part here says, second part हमें बोलता है कि modulus of z हमेशा 0 से बड़ा होता है. So हमेशा 0 से बड़ा कब होगा? जब तक कि हमें इसका मॉडुलस 0 के बराबर ना मिले. मतलब 0 के बराबर नहीं मिलना चाहिए. अगर 0 के बराबर मिलता है तो इट विल बी दिस कंडीशन, एंड अगर लेस देन 0 तो होता ही नहीं है मॉडुलस, और मोर देन 0 होने के लिए हमें 0 के बराबर नहीं आना चाहिए. सो वी कैन से दैट इट शुड बी अ कॉम्प्लेक्स नंबर. It should be having its both the components not equal to 0, like x or iy, which will be not equal to 0. Either this or both. Either this part satisfies or this part satisfies, or we can say that both the parts satisfies, then also this part gets satisfied, and then finally we can say that the modulus of complex number will be greater than 0. This is the first property. Let's do it with an example now. Taking an example for this, we can say that the first part, it says here, first part will be discussed now. The first part में क्या होता है? Actually it says we need to have both the real part and imaginary part as 0, so that its modulus will be 0. So let's take, if we have a complex number 0 plus 0i, and if you try to find out its modulus, then what will be the modulus? Modulus का फॉर्मूला क्या बताए थे हम? रियल पार्ट का स्क्वायर रूट. सो रियल पार्ट इज 0 का स्क्वायर प्लस इमेजिनरी पार्ट का स्क्वायर रूट. Imaginary part is also 0, so 0 का square. It finally becomes what? 0 square plus 0 square results into 0. This condition satisfies with this. Now for the second part, if we try to do the second part का example अगर हम लोग लेंगे, तो second part में क्या होगा? हमारे पास एक complex number होगा. कोई भी एक complex number at random हम ले सकते हैं जो कि ये condition satisfy करे. Suppose we can have only real part is not equals to 0, then it's okay. Its imaginary part, only imaginary part is not equal to 0 and real part is 0, then also it is okay. And if both the parts are not equal to 0, then also it satisfies the condition. So let's take a complex number which has both the parts not equal to 0. So doing this, we can take example like 2 plus 3i. It's both the part, like real and imaginary part, are not equal to 0. So we can say that its modulus will be under the root. The formula क्या था? पिछले बार हम लोग बताया था फॉर्मूला, स्क्वायर रूट ऑफ रियल पार्ट. स्क्वायर ऑफ रियल पार्ट का स्क्वायर आ जाएगा 2 स्क्वायर प्लस इमेजिनरी पार्ट का स्क्वायर आ जाएगा 3 स्क्वायर, विच इज नथिंग बट अंडर द रूट हो जाएगा आपका 2 का स्क्वायर 4 प्लस 3 का स्क्वायर 9, isn't it? So let's go further with this. It finally becomes 13, under the root 13. That will be that is not equals to 0. We can see here it is not equals to 0. So we can say it is greater than 0. And since it is greater than 0, we can say that this property supplies, and this property is proved to be true. Finally, this property is proved true by this. Okay. Guys, hoping that you must have gained some knowledge out of the previous talk, which we discussed the subject and the concept. So hoping that will be useful to you, and if you find it useful to you, really beneficial to you, then do subscribe the channel, do appreciate us by liking the video, and do share us as much as possible, so that will give us the boost to our morale, and then we continue doing it. And do not forget to follow us on our Instagram. That is, our ID is Instagram ID is @uniform additioners. without any space in the middle, we can say that this is our Instagram ID. Do not forget to follow it on Instagram so that you get the updates and the image of the complex image of the concepts of the class which are discussed. And also we are trying to focus on other subjects like English, their grammatical rules, then the vocab part, then the idioms and phrases. They are uploaded in a day-to-day manner to get the students the more beneficial as much as possible. With this, I take leave of you. Thank you and Jai Hind. Stay home, stay safe. Take care of yourself.